done. Do you remember the equation for the work done for an adiabatic process? I thought it was a simple equation. Work done in an adiabatic process is P1 V1 minus P2 V2 over gamma minus 1. For that, we've got P1, we've got P2, we've got V2, but we don't have V1. That means we need to now go and solve for V1. Now, how will we obtain V1? Well, we have P1 and T1. If you have P1 and T1, we can find V1 using the equational state. V1 equal to nR T1 divided by P1. Is that right? And all these values we know. T1 you know is 500 Kelvin. P1 is 5 atmosphere. Write that in Pascal. That gives me V1 is 0.0041 meter cube. Now you have P1, V1, P2, V2, and we have gamma. We can calculate the work done. Adiabatic work done is P1, V1 minus P2, V2 divided by gamma minus 1. But all we need to do is use all these values. Remember to do them in absolute unit. Pressure must be in atmosphere and volume must be in meter cube. So you can see what I have done. I have taken 1.01 times 10 to the 5 outside so that I don't have to multiply for each. I'll be 5 times the volume is in meter cube minus 1 times V2. You see, P1 V1 minus P2 V2 and multiply that by 1.01 times 10 to the 5 divided by gamma minus 1, and that is 1471 joules is the amount of work done. Now this problem in fact consists of all the principles we discussed so far in adiabatic expansion. So if you can do this problem, you can do any problem. Okay, and finally the quantity of heat added, dQ equal to du plus dW. Well, of course dQ is 0 for an adiabatic process. So dW equal to 1471 joules. Therefore, what is du? du equal to negative 1471 joules. What does that mean? It means the energy needed to do this work is taken from the internal energy of the object. That means the internal energy decreased by that much quantity. When the gas did so much work without getting heat from outside, it took energy from the internal energy. Therefore, the internal energy decreased by that much quantity. Okay, let's do another problem. An ideal gas at a temperature of 20 degrees Celsius and at a pressure of 1 atmosphere is compressed to quasi-statically and adiabatically to half its original volume. You see, the moment you see half its original volume, you must say immediately, aha, V1 divided by V2 equal to 2. You see, that quantity come very handy. It is compressed to half its original volume. V1 over V2 equal to 2. Find its final temperature and pressure. If CV equal to 3 over 2 nR, that is a monoatomic gas, and CV equal to 5 over 2 nR, that is for a diatomic gas. Alright, let's pick out data. P1 is 1 atmosphere. T1 is 20 degrees Celsius, always converted to Kelvin. That is 293 Kelvin. V1 over V2 equal to 2. Is that right? The gas has been compressed to half its original volume. So the initial volume is 2 times the final volume. V1 over V2 equal to 2. Alright, let's take case 1 where CV equal to 3 over 2 NR. If CV equal to 3 over 2 NR, then CP will be 5 over 2 NR, and that means gamma will be equal to 1.67. Actually, we don't need that step. You know, for a monoatomic gas, gamma is 1.67. So the only difference between A and B is that in A, gamma equal to 1.67. In B, gamma equal to 1.4. So I will only do part A. You must repeat part B using the different value of gamma. For an adiabatic expansion, alright, what are the equations for the adiabatic expansion? We got 2 equations. TV to the power of gamma minus 1 is a constant, or PV to the power of gamma is a constant. Now, which of that are we going to use here? Well, we're going to use TV to the power of gamma minus 1 is a constant because we want to find its final temperature. So we have the initial temperature, we want to find the final temperature, so we use TV to the power of gamma minus 1 is a constant. Now what does this mean? It means T1 V1 to the power of gamma minus 1 equal to T2 V2 to the power of gamma minus 1. Alright, now can you rewrite this equation in such a way that it will contain V1 over V2, because that is known to us. Can you rewrite this equation in such a way that it will contain V1 over V2? Yes, T2 over T1 equal to V1 over V2 to the power of gamma minus 1, isn't it? T2 divided by T1 is V1 to the power of gamma minus 1 divided by V2 to the power of gamma minus 1, which is the same as V1 over V2 to the power of gamma minus 1. You must have the ability to look at equations like this and rewrite them. So we have now rewritten this equation so that we have the quantity V1 over V2 introduced there. Now you know V1 over V2 is 2, gamma is 1.67, T1 is 293, you can find T2. You see how simple it is? Now, this will be 2 to the power of 1.67 minus 1 is 0.67. And what is 2 raised to the power of 0.67? Use a calculator for that. It is 1.59. So T2 over T1 equal to 1.59. Therefore, T2 equal to 1.59 times T1. And T1 is 293 Kelvin. So that will be 1.59 times 293. That is 469 Kelvin is the final temperature. Alright, to find the final temperature, we used this equation. Now, we want to find the final pressure. What will we do? Well, to find the final pressure, we use the other equation. PV to the power of gamma is a constant. Now, don't confuse between here. TV to the gamma minus 1 is a constant. PV to the power of gamma is a constant. Alright, let's do that. Using PV to the power of gamma is a constant, we have, how will this be written? P1 V1 to the power of gamma equal to P2 V2 to the power of gamma. There you are. Okay, can you rewrite this equation so that it contains the quantity V1 over V2. Yes, it will be P2 over P1. You can see here P2 divided by P1 will be V1 to the power of gamma divided by V2 to the power of gamma. Or P2 divided by P1 is V1 divided by V2 all to the power of gamma. And now you know V1 over V2, you know gamma, you know P1, therefore you can find P2. So this will be 2, V1 over V2 is 2, 2 to the power of gamma is 2 to the power of 1.67. Use a calculator for that, that is 3.18. Therefore P2 is 3.18 times P1, and P1 is 1 atmosphere, therefore P2 is 3.18 atmosphere. Okay, that's a very neat way to solve problems like this. Okay, and now I told you I want you to do the second part on your own. The same problem, the only difference is the value of gamma in this case will be what? When CV equal to 5 over 2 nR, Cp will be 7 over 2 nR. It's a diatomic gas. The value of gamma is 1.4. So do that on your own right now. Actually, don't just go away. Just sit there and do the same problem on your own. Okay. Let's do another problem.